So good morning to everyone. So in this last class we have seen the DAC interfaced with the LCD for the PIC microcontroller application. So in this class we are going to see about the timer applications interfacing keypad. So in this slide we are having the ADC conversions and interrupt timer applications interfacing with the keypad. So likewise we are having that keypad interfaces with the PIC microcontroller to display the whatever we are giving the text, it will be displayed in that LCD. So these are the schematic diagram. Here I was using that Proteus software to interface all the simulation experiments. So the Proteus software will be used for the simulation which we are doing that projects in the real time, whether it's a feasible or not, and all the interconnecting procedures also we can do by that Proteus software. So other Arduino will be used for the Tinkercad and other simulation software also is available. So now we are using that Proteus software to interface that PIC microcontroller with LCD and keypad. Okay, so in this we are having that PIC 2-wire keypad interfaces using 555 timer using PIC microcontrollers. So in this keypads are very essentially common used input devices based on the system. So in keypad multiple switches are arranged in the rows columns so that interface with the microcontroller with a minimum number of IO pins. For example, 12 keypad is arranged in a 4x3 format which allows the interfaces. The 12 key is used to microcontroller with only a 7 connections. The location of each key on the keypad is defined by the coordinates and the locations of each key is connected in the defined by the two coordinates, the row and the column. So when the key is pressed, it connects its row with the columns. The microcontroller must scan all the rows and columns to find out which key has been pressed. This scan most common way of interfacing the keypad to a microcontroller. There are tons of resources in the internet regarding this technique, so that can be discussed clear. So today we are having that techniques called 555 IC timer is a stable multi vibrator. This divided into two resistors and a capacitors as shown in the figure. So this is my interfacing diagram which is used for the 555 IC timers to interface with the PIC microcontrollers. So that operations behind that when key is pressed, a certain value of R resistors is connected between the 7 pins and the 6 threshold pins of the 555 IC timers, completing a stable multi-vibrator circuit. The output pulses are counted for 100 microseconds and through a timer module in the microcontroller. So the microcontroller determines the pressed key in the from the number of times timer has overflown. If the timer module overflow 5 times, the key pressed is 5. Similarly, if a key 0 is pressed, the timer doesn't overflow the 100 times. Is simple now. So the circuit diagram is given in the above. The value of R1 and C is 1 kilohertz, 1 kilo and 0.01 microfarad. The following table shows the different value of R2 for each keys, the corresponding frequencies and the number of times the timer 0 module overflows. Some of the resistors can made combining two resistors together. Okay, so these are all the applications will be used for that interfacing that LCD interrupt functions with the timers. So in this class we have completed this experiment. So in the next class we are going to see about the IO programming of the PIC microcontrollers. Thank you.